Good morning, everyone. My name is Nguyen, and I am a first-year direct PhD student with Regal and PEC under Dr. Ali Murizi Sani. And today I'm going to present the work Virtual Reality Augmented RTDS-Based Digital Twin for Power Grid Operator Training that just recently got accepted at PSGM 2026. As we all know, the power grids are critical infrastructure and need to operate reliably at all times. Utility must maintain highly skilled personal workforce to operate the power grids. However, the current power industry workforce is quite old and had a high retirement rate. Actually, it is estimated that by 2030, 40% of utility workforce will be retirement eligible. Another big challenge in the field is the emergence of new technologies such as renewable energy and grid digitization. All of these reasons make it much more challenging to train new power system workforce, such as operators and engineers. This work proposed a virtual reality training environment that would augment the traditional training program to provide a better hands-on experience with operating at the grid level. For our virtual environment, we employ a VTES substation replica created in Unreal Engine 5. And to the left here, you can see the VTES substation located in Blacksburg. And to the right, you can see the virtual replica of the VTES substation rendered in Unreal Engine 5. To make this highly realistic model, first we need to take a $200,000 camera to a high vantage point to take the point cloud scan of the entire substation. This would allow us to know the accurate position of the electrical equipment and adhere to substation standards when placing them in the virtual environment. Next, we need to create the 3D model for the electrical equipment, such as the transformer right here. And then we need to add the texture to the 3D models to make them look realistic to the actual electrical equipment. For the digital twin part, we leverage a real-time RTDS-based VTES digital twin developed at PEC and a UDP-based communication network. This here is a diagram of the data path of the VR environment. The trainee can operate the digital twin grid through the VR headset using interactions such as hand tracking, gesture, or user interface in the environment. Measurement from the digital twin grid will be displayed in the environment through the metering system and real-time SCADA. This would allow for training scenarios usually not available in traditional programs such as severe weather to be realized. For demonstration purposes, we are using the IEEE 13 feeder system due to the confidentiality of the VTS system. The first case is de-energizing a line due to scheduled maintenance. And this here is the metering system, and the one below here is the real-time SCADA system that we have developed in the VR environment. For this scenario, the power grid is operating in the nominal condition, and all breakers are in a closed state. Due to a scheduled maintenance on the line between bus 671 and bus 692, the trainee must operate the R1 breaker control to disconnect and de-energizing the line. The live graph feature of the SCADA panel also captures the nonlinear dynamic of the power grid after breaker R1 has been changed. This here shows the bus 650 three-phase power after breaker R1 had been disconnected. And phase A, the real power dropped from 1.3 megawatt to 0.76 megawatt. And for reactive power, similarly, the reactive power dropped from 1.12 megavar to 0.1.12 megavar to 0.81 megavar. Same direction can be observed from phase B and phase C of bus 650. For the second scenario, the trainee needs to restore the bus voltage to its nominal condition. In this scenario, due to a change in the grid load profile, bus 671 experienced an undervoltage on phase C This here shows the bus voltage, the graph, and as well as this meter show the bus 671 voltage. The trainee is tasked with restoring the bus voltage to its nominal condition. The operation consists of changing the voltage regulator tap from 7 to 11, connecting the capacitor bank at bus 675, and disconnecting the non-critical loads at bus 692. After the grid undergo a load profile change, the voltage at bus 671 dropped to 0.94, 1.0, and 0.85 at phase A, B, and C. And after the trainee have done the correct sequence within the time frame, the voltage of bus 671 got restored to 0.99, 1.04, and 0.9 per unit at phase A and BC respectively.